Great. How you doing? All right. Can everyone hear me okay?
Loud and clear, Joe.
Let's just make sure we're doing good. Excellent. Let's get started. So once you give me the handoff, looks like the handoff is done. I'm just going to check to make sure you guys can see my screen.
Yes, Joe, we can see your screen.
All right. Great. Okay, everybody. Let's get started. We're going to be talking about the ECSP. We're going to be talking specifically about .NET security and where you can go with .NET security. So you're gonna have to kind of bear with me because I'm gonna kind of start from the bottom and bring you up. So I'm gonna open up a quick PowerPoint right quick. I'm gonna go through this pretty quickly so that we can get right to the meat. Okay, let's make sure you can see my screen okay. All right, looks like you're following me. So let's start with our first vulnerability, and that's SQL injection. Okay, I'm just waiting to make sure that the screen is refreshing. It looks like it's not refreshing. Let's try again. Okay, now it looks like you guys are seeing my screen okay. Okay, so when we're dealing with SQL injection, the primary thing that happens with SQL injection is the most basic with all programming. And what that is improper string termination. So what ends up happening is, let's say you have somebody who declares an integer. So you see that I'm going to say something like int equals 51550. And it's perfectly fine to declare an integer this way. But if you look at the next line below it where it says string equals Joe, you'll see that what I've done is I've had to put Joe encapsulated in quotes. And that's the simplest of things, right? It's because computers are great with numbers, but they're horrible with strings. So we've got to encapsulate our strings in quotes. You'll see in my very bottom line it says string 2, and it's got Joe space McCrae also encapsulated in quotes. Now we've all made this mistake in development. If you look here, you'll see that my strings aren't properly terminated. I've got int, I've got 51550, and then I've got a tick at the end of it. So it's an improperly terminated string. The same with the two lines below it. I've got a string with a tick on one side and then a string with two ticks on the other. You look down at string 2, same problem. This commonly throws an error like what you're going to see here on this next slide, where it says Microsoft OLE, Object Linking and Embedding, DB Provider for SQL Server, and it tells you you have an unclosed quotation mark after the character string, right? We've all made this mistake. Common to programming, common to programming. So let's say we have ourselves an SQL query. So if you look at the SQL query in the middle of the box, in the middle of the slide where it says string query, select all records from products where product ID equals request, and then you see in brackets ID. And it's letting you know that that request is coming from the web. And when you look at the very last line of the slide, you'll see HTTP site.com/products.asp ID equals 51550. And that 51550 is what's going to be inserted into the same space as that ID. Now, if we look at this next slide, what happens here? We see that we said site.com, products.asp, question mark, ID equals 51550, and now we have inserted a single quote at the end of the address bar, at the end of the URL. You'll see what it does to the actual request. You see how it messes up your select statement? So now you have this request ID where request equals double quotes on one side, 51550, and 3 quotes at the end. Well, that's going to cause an error. That's going to cause an error. Now what you've done is basically the same as this int equals 51550 tick. Same problem. You should get an error that says you have an unclosed quotation mark. This is what's happening when an attacker is triggering SQL injection in your website. Now, when an attacker actually tries to utilize this and attack it, he's going to need to not just trigger the error message, he's going to need to actually inject code. Now, when he injects code into the website, that's when you're going to see like this web URL I have in the middle. Products.asp, ID equals 51550, or 1 in select user. And if you see that, what that does is that translates the query to select all records from products where product ID equals, and then you have in that request bracket 51550 or 1 in select user. So the tricky part to that is to say, okay, what do you mean 51550 or 1 in select user? Let's look. How does that work? Why does that work? So I always make the joke, like, who was asleep in math class, right? So if you look at something, and let's say we have a number, 5 equals 3 plus 2. So we've got this little equation. And when we look at the next line of the equation, how is that different from 5 equals 1 plus, in parentheses, 2 plus 2? So I always say, what's implied by the parentheses? Well, order operator precedent, right? Whatever's inside of the parentheses needs to be executed first. So as soon as you realize that, you go, oh, well, that's easy. So what that means is when I'm attacking a URL and I have that or 1 in select user, the select user in parentheses, that's what's going to be executed first. Okay. So the result of that select statement is going to be the answer DBO. Pretty easy. I can handle that. But what about the rest of the equation? So what about that in, or 1 in? Well, in is basically another way of saying equals. So what you've done is you've just said 51550 or 1 equals DBO. Now, when you see an equals versus a double equals, the single equals is an assignment. The double equals is a test condition. So in our case, we're saying this single equals is an assignment. You're saying that the integer value of 1 is equivalent to the string value of DBO, which was the result of the select user statement. So 51550 is an integer. DBO is a string. You can't just assign a string to be an integer or vice versa. It's going to throw some sort of error. Without some sort of casting operation or conversion operation, you can't just assign a string to be an integer. Now, we're planning on that. We're betting on that. We as attackers are hoping for that to work in our favor, because what it does is it generates an error. And when you generate the error, the result of the select statement gets encapsulated in the error message. We call this error-based SQL injection. So you're going to see me in the next few minutes start doing some demos where I'm using this against an ASP.NET enabled website. Then we'll start to talk about the security mechanisms that ASP.NET adds, and then I'll show you how you can yet again bypass even those security mechanisms. That's going to be the reason why, even though a person may be really comfortable with .NET and know that .NET now, for example, has things like the anti-cross-site scripting library and request validate and several other security mechanisms that are built into it by default. That doesn't mean that they still can't be bypassed. That doesn't mean that you still don't have to take care when writing secure code. You know, you can't just be all willy-nilly, even though new security mechanisms are in .NET. Yes, .NET is more secure than it's ever been before, but that doesn't mean we can be totally negligent with the code that we write. So let me finish up with this last part. My last question that I often get asked when we discuss SQL injection is why the 1 equals 1, why the A equals A. So real quick, let's say we have a table, and we can see in the table that we've got users on one side, one column, passwords on the other, username admin, password, username Jim, password Bean, username Johnny, password Walker. So let's say we have some source code that we convert to this. Now, if you look, you see that we have a if, and then in parentheses, username and password, and because they're in parentheses, it's a test condition to see if they're true. So the logic behind this is to say if there's a valid username and a valid password, allow the user to log in. But we can play with that. If you look at this next slide, you'll see that we say if $username, what if you put a Joe in there? Well, Joe isn't in the username column. So you say if username Joe or 1 equals 1. Well, 1 equals 1 is a valid record. So the left side of this equation is true. Now you have your AND statement, and you have Joe or 1 equals 1. Well, Joe is not a valid password, but you have a or 1 equals 1. So that balances out this equation. Both sides of the AND statement have a logical true condition in them now. So I always make the joke where I say, well, have any of you heard of this project management professional certification, the PIMP, you know, as I like to affectionately call it? And I always make the joke that I want to be a pimp too. So if you look at this and we're on the PIMP site, you can see that the PIMP site let me log in as user A equals A. And when you log in as user A equals A, it's usually allowing you to be the first record in the database. So if you go back and you look in that first record in the database, that's admin. I notified them of this, and they fixed it. They were a little upset with me for doing it, but at least they fixed it. So I'm going to stop there, and I'm going to jump on and do some demos. So if you just give me 1 second to switch gears here. Now, we're switching gears to a web browser. And you're going to see that it's an ASP.NET website. So it's the latest version of ASP.NET. It's running on Server 2003. I'm sorry it's not on 2008, but next time I rebuild this, I'll put it on 2008. It's SQL Server 2005. When I click on one of the links, you can see that there's parameter passing. So you'll see with the parameter passing, it's ID equals 1. So it's bookdetail.aspx, so ASPX is the .NET version of the page. Question mark. So the question mark lets you know that parameter passing is in use. ID equals 1. So ID is the parameter name and 1 is the parameter value. Now I'm going to insert a single quote here. When I insert my single quote, you see that I get this error page, right? And it says unclose quotation mark after the character string. Okay, so we see that that's what's going on. We see that we have a valid SQL injection. Now bear in mind, I've set this website up so that verbose error messages are turned on. A little bit later in today's demo, I'm going to show you a properly configured website where verbose error messages are turned off. And all of the other .NET security mechanisms are enabled, and I'll show you how we bypass that as well. So if you take a look here, you can see that verbose error messages are turned on, you can see the entire select statement. You can see all the connection string information, right? You've got a full stack trace here. So this is bad. This is really bad. So a lot of people, because they know by default they're dealing with ASP.NET, they don't test the websites as thoroughly, and that's just my personal opinion. I don't really have a lot of proof to back that up other than just conversations I've had with people. You know, because ASP.NET has so many new security controls, when a lot of people start to test for things like cross-site scripting and SQL injection, they find them kind of difficult to pull off. So I'm just going to go through a couple real quick. Let's say we do an OR1 in select user. And then here you can see that the result of that user query, select user, is DBO. This is exactly like what we had on the slides. Now I'm going to go for select at version. So this is the database version. And you're going to see here that we're able to see that it's SQL Server 2005. Running on Server 2003 Service Pack 2. So this SQL injection stuff is working great. But if the website has verbose error messages turned off, even if there is SQL injection, you won't see stuff like this. So what I'm going to do is I'm going to give you like a really quick little trick. So you see that I have ID equals 1, and it gives me this book called Don't Make Me Think, right? But if I change it to ID equals 2, you see that I get a different book, right? A Guide to Wireless Engineering. I see the difference in the book. So here's ID equals 1. That's the Don't Make Me Think book. Here's ID equals 2, and this is the Wireless Engineering book. So what I'm going to do is in parentheses, I'm going to say 2 minus 1. So now if I have in parentheses 2 minus 1, and I get the same record as ID equals 1, we've just proven that SQL injection is there and possible. Because we're passing an arithmetic function to the database, and the database is evaluating it. So even if verbose error messages are turned off, if you can pass arithmetic functions like that, you've just now proven that SQL injection is possible. There's lots of tricks just like this. This is called inference-based SQL injection. You're trying to make the behavior of the website help you infer whether SQL injection is possible, not necessarily having to have an error message. So there's so many cute little tricks that you can do. So we already talked about that 1 equals 1. Let's go ahead and let's give that a shot. And let's see if we can see that in action. So what I'm going to do is I'm going to throw in the OR1 equals 1. So I've asked for record number 2, OR1 equals 1. But then you look at it, I get a valid page. Now what I'm going to do is I'm going to change that to record equals 2, OR1 equals 2, a negative page. And you guys are going to notice that the page changes. So now I have a true-false test condition that proves that SQL injection is possible. So now what you can do is you can couple Boolean logic with it. So you can say ID equals 2 and select user equals DBO and 1 equals 1. Now if all three components of that expression are true, you get the same page as 1 equals 1. If one of those components, like the username, is false, you'll get the same page as ID equals 2, like this. So this is another way that you can do that inference even if verbose error messages are turned off, which is going to be pretty common in modern web applications. Okay. The next thing I want to show you guys is something called an order by. So with an order by, what we're trying to do is enumerate the number of columns that are in a specific page. So I said order by 100, so I have ID equals 2, space, order by 100. And you see that it says order by position 100 is out of range. There's not 100 columns in this table. So I'm going to change that to order by 50. So you see when I do order by 50, I get another error message. Order by position number 50 is out of range. So I know that there's not 50 columns here. So I'm going to do the same thing. Let's order by 25. I order by 25. It gives me the message saying that there's not 25 columns here. We're back in the same boat. Okay, how about I order by, let's say, 15? Tells me there's not 15 columns. Son of a gun. Okay, how about I order by 10? I order by 10. Geez, there's not 10 columns. Okay, how about I order by 5? I do that, I get a valid page. Okay, so I know that there's more than 5 columns, but less than 10 columns. So how about I order by 7? I get a valid page. How about I order by 8? I get a valid page. I order by 9. I get a valid page. So we already know there's 9 columns. If I check it by doing an order by 10, you'll see that I get another error page. So I'm going to go back to order by 9. And what I'm going to do is I'm going to fill out the placeholders for 9 columns. And I'm going to fill that out with a union all select statement like this. Now, this is important, right? You see that this worked because I got a valid record in the database, a guide to wireless engineering, right? It's a valid record. Okay? So, if that's our case, well, why did I make you do that? Well, if you want to test the union select statement, you'll see that the syntax required is your union query must have the same number of fields in the result sets with similar data types. So your union statement joins 2 select statements together. You're going to join the developer's select statement that he wrote for the website with your own select statement for stuff that you want to enumerate from the website. The problem is you have to have the same number of fields in the result set. So we needed to know how many columns were in this table. So that's why you're going to see that we're going to say, okay, now we go union all select. Now, this record is valid. A guide to wireless engineering body of knowledge, that's valid. So what I need to do is I need to negate that field. I do that by turning the ID equals the actual parameter value into a negative number. Doing that negated that value, and now you see these numbers show up here on the screen. I got a 7, I have a 2, I have a 3, a 4, an 8, a 9. So let's start with this 7 right here. So I got this 7 at the top of the screen. That means in placeholder 7, right up here in the address bar, I can replace it. So let me replace it with at version. And now you'll see that it reports my SQL Server version right here. See, Microsoft SQL Server 2005. It reports all of that stuff. So everywhere that there's a number on the screen, in the address bar, we can replace that with the select statement values that we're trying to enumerate from the database. So we can throw in as much data as we want, as many SQL requests as we want, and we can start yanking data out of the database. This is called union-based SQL injection. The first one that we did was error-based. This one is called union-based, because you're doing it through a union statement. There's one other type of SQL injection that I want to show you, and that's called blind SQL injection. So what happens with blind SQL injection is, I'm just going to say semicolon, wait for delay, and I'm going to make it wait for 10 seconds. So if you take a look at what it's doing right there, you'll see in the top corner, this page is just spinning. It's waiting and 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 waiting. And then after that, 10 seconds elapse, I get a valid page. So the wait for delay is working. So let's say you're up against a website where they don't allow you to do your error-based SQL injection, and for some reason the union results aren't displaying to the screen, right? So your wait for delay method is a really good trick. It's called blind SQL injection again. So what you do is you put an if statement right in here. You'd say if username is DBO, wait for delay 10 seconds. And then you would see that it would wait, and then you could infer these. So if the first letter of the password is a P, wait 10 seconds. If the second letter of the password is an A, wait 10 seconds. So that's inference-based SQL injection, also called blind SQL injection. So now that we've ripped through some of those SQL injection types, I know I'm going fast because I really got to get through and show you guys some other stuff. I want to show you guys a little something about cross-site scripting. So I'm going to switch over here to my slides, so just give me 1 second. So I'm going to open up my cross-site scripting slides. Okay, see if you guys can see my screen yet. Okay, looks like it's a little slow catching up to my screen. I'm waiting for you guys to see my PowerPoint. There you go. Okay, so now you guys can see my screen, cross-site scripting. Okay, still waiting for your screens to catch up. Let's see if that, there we go. Okay, now you guys are with me. Okay, so here we're going to do Introduction to Cross-Site Scripting. And with cross-site scripting, we've got to get over a barrier. Most people are really on board with SQL injection. They see SQL injection, they know that you're stealing data out of the database, and whatever's in the database is usually pretty important. That's why it's in a database. Cross-site scripting is one of those vulnerabilities that a lot of people don't understand it very well. And because they don't understand it very well, they don't think it's as critical. So I need to kind of get you over the hump. So let's start with, how does Internet Explorer differ from cmd.exe? If you have cmd.exe, that's your command prompt on your machine, that allows you to drive your computer, open up files on your local file system, start and stop programs, processes, and you can manage your whole computer through your command prompt. So the question is, how does cmd.exe differ from Internet Explorer? Well, can't Internet Explorer read your local file system? Can't Internet Explorer launch programs? So if you really kind of think about it, everywhere that you go on the Internet, when you browse to a website, you're functionally giving them a command prompt on your computer. That's how you got to start looking at your browser. When you start looking at your browser as a command prompt on your machine, and every website you go to, you're giving that website a command prompt on your machine, that's the context that you need to think about that's the context that you need to have when you're thinking about cross-site scripting. So we need a reality check, right? The way that your web browser works is to start at the top of an HTML page and just read until it gets to the bottom. That's all it does. Your web page, your browser literally just goes to a website and goes, oh, here's some code. Let me just read it. It just renders it, just starts and just reads to the bottom. It really doesn't know if the code on the website is good or bad. It doesn't know if the code on the website was submitted by somebody else. It does not know that. And because of that, dynamic content websites, websites where users can contribute content to the website, are the highest of risk for being hit with cross-site scripting attacks. So remember, like I said, your web browser just starts at the top of the page, reads all the way down to the bottom. So when it sees script code and JavaScript code and VB script code, it really doesn't know where it came from. So let's say you're at a dynamic website, like a blog, a forum, a guest book, any component in the website that's dynamic, where users can insert content. Well, if users can insert content and they start inserting script code in that, when your browser goes to read it, it just sees a line for a JavaScript call. Script whatever, document dot whatever. And your browser just runs it. Because to your browser, it's all coming from one site. Even though multiple people may be contributing to the code on the site. So we always need to think about anywhere where we have dynamically generated or user-generated content, search boxes, blogs, forums, guest books, contact us forms, feedback forms, instant messenger, chat, anywhere where users are allowed to interact with the website. These are the places that you need to really be conscious of, and you need to think about anything that the user inputs. Will it ever be displayed back to that user or another user as executable code? That's what you need to be thinking about. So like I said, let's say you have a website and you have some lines of script code. Your browser can't tell what lines of script are good or bad. If it sees a line of script, your browser doesn't know that this script code came from another user in the website. We need to make sure that anything that comes from a user is not executable. Okay, so now we need to really start thinking about how a web server knows who you are. Because HTTP, the protocol itself, is stateless. So from one packet to the next, the web server does not know who I am. It doesn't freaking know. So the web server is going to utilize either parameter passing in the address bar or a session cookie or the combination of the two. So your session ID is generally a long string of information, or maybe even several strings of information that say who you are and where you are in the site. And then we obviously already know what parameter passing is. So having things like ASP session ID, JSP session ID, PHP session ID, these are the things that you want to implement because they have very high entropy. We don't have enough time to go into all that stuff today, but when you take the class, we'll really get into utilizing entropy so that you don't have things like session fixation and other session-related attacks. Okay, so now the goal of cross-site scripting. The goal of cross-site scripting, the generic goal, is the attacker will usually try to capture your session ID. Then he's going to take your session ID, right, because that's how the web server knows who you are, and he's going to send that session ID to another server, cross-site. And then he will attempt to use your stolen session ID to log into the website as you. Okay, let's switch back and let's go for some demo action. Okay, so we have this page here, and this page is what I use when I demo cross-site scripting. So in the search box, we're just going to do a generic script alert, the most common thing that anyone ever sees when people talk about cross-site scripting. So it's just script alert, and then it says, so this is XSS, and it gives you the pop-up box. And now you can see, oh wow, I have cross-site scripting. Okay, well this is normal, right? Everyone's seen this. The problem with this is non-technical users, generally look at that and go, so? Why do I care about something like that? That's stupid. It's just a pop-up box. So I'm going to click OK. I'm going to hit my back button. Now, what's important here is that you've proven that you can execute code in the context of someone's browser. Remember, a browser is just like having a command prompt on someone's machine. So you're saying I can execute code on your machine. It's almost like saying, hey man, I got a command prompt on your machine. If I can execute stuff in the context of your browser, it's like having a command prompt on your machine. So what we're going to do, the first thing is to prove that you can get code execution. That's what the pop-up is for. Proving that you have code execution does not mean that you can pull off cross-site scripting. So the next thing that we want to do is your same script alert, but instead of just doing a pop-up that says cross-site scripting, inside of that I want to do script alert document.cookie. So script alert document.cookie. What I want to know is, do I have access to your session cookie? So the first part of the cross-site scripting test is to say, do I have code execution? Okay, yes, I have code execution. The second part of that is to say, okay, can I have access to your session cookie? So if I have access to your session cookie, now it's getting a whole lot more interesting, because this is the thing that proves that you are who you say you are. Okay, so if I have access to that, now it's going to get really interesting, because now what I want to do is I want to send that session cookie somewhere else. So now what I want to do is I want to send that session cookie across site to another site. So you're going to see that it's going to, you're going to see that I'm sending it to a page, cookiecatcher.php. Question mark C is the parameter for cookie, and what's being passed to that parameter name of C is this PHP session ID. So now we just sent the cookie across site somewhere else. Does that make sense, guys? We just sent it across site. We sent it somewhere else. So now what we need to do is we need to have a page that allows us to view the stolen cookie. Now our cookie catcher does that. It writes the cookie values to a text file for us. So let's take a look at that. Beautiful. So now you'll see that this thing, every person who's clicked on that link, their cookie gets sent somewhere else. And that's exactly what we want, right? It gets sent to our malicious website that captures cookies. So what's really happening here is when a user is logged into a website and they click a link, when they click that link that captures their cookie and sends it somewhere else, you can only do that because they're logged into the website, right? This is why you're going to see people utilize cross-site scripting in places like blogs, guest books, email accounts where they know that you're going to be auto-signed into the website that they're attacking. So if you're a developer developing dynamic content websites, and what website today isn't dynamic, you're really going to have to think about this stuff. Okay, let's make ourselves a little switch here. Okay, so I like using Internet Explorer for this quick little demo. So what I'm going to do is I'm just going to go to Amazon.com, So I go to Amazon.com. You can see that I'm here at Amazon.com. And I just want to kind of show you what cookie tampering looks like. So right over the address bar, I'm just going to write JavaScript :void document.write document.cookie. And when I do that, you'll see the session cookie. You guys see it here? Session ID, session token, all this stuff is right here. So you have this huge, nasty, big session ID thing here. We can see, okay, there's the session ID. So let's say now I want to overwrite the session ID. I want to modify it. So I want to say, JavaScript :void document.write, PHP session ID equals ECSP -is -cool. Probably need to throw a parenthesis in there, right? That looks right. Let's delete that. Let me just check my parentheses here. Okay, I'll hit enter. Hit enter again. I'm going to hit my back button. We'll go back to Amazon.com. Now I'm just going to test it with the document.write document.cookie. The demo gods must not love me. Okay, let's try that again. Oh, okay. Yeah, I did it wrong. Right there. ECSP is cool. All right, so we'll hit enter. Do that again. And now you can see that the session ID has been overwritten. Okay. So this is how an attacker can use this. He can take your stolen cookie, he can go to a website, he can modify that, override it, log into that website as the victim of the cross-site scripting. So like I said, cross-site scripting, because it's such a misunderstood attack, people often don't realize that you're attacking the user. The user is at risk, not the server. The server is fine. The problem is you're going to have people logging in as other people. So I'm going to switch gears right now. I'm going to flip back to Firefox. Okay, and we're a little pressed for time, so I'm going to have to move kind of quickly. So I'm skipping a couple of things that I had hoped to cover. What I'm going to show you right now is a banking website, and what we have on this one is a trading web application. And what we have here is you're going to notice that when I try things like cross-site scripting, I get hit with what's called request validate. You're going to see this stuff sucks. So you see that I'm trying my generic cross-site scripting, and he's all kinds of not liking this. Let's see if the web page catches up with me, guys. Just going to put it on the screen. There you go. So you can see here that these are the types of error messages that you're going to get, and you're going to see that your web.config file is what sees these things, right? And your web.config file applies configuration and security settings to the folders that it's in. So if you have multiple web.config files, you'll have multiple sets of configuration and security settings. So when you're trying to deal with a modern ASP.NET application, this is the guy that you're going to find yourself running into a lot. So it's because of this that I think people don't test ASP.NET applications as hard as they should. So you can see right here that it just passes a parameter. The search box gets passed as a parameter in the GET request. Let's take a look. Okay, there's our cross-site scripting attempt. And we can see that it's search result.aspx script name equals, and then here's my cross-site scripting attempt. I can show you a trick that works with ASP.NET. I'm going to copy this, delete it, flip over here, and insert this like that. And now you see that cross-site scripting actually works. Okay. What I just did was I just replaced in the web request the parameter name with the parameter value. And this is because the security control called request validate in ASP.NET only tests the web parameter value for cross-site scripting. So these are a lot of those little tricks that a lot of people don't know. So if you have a dynamically generated parameter name for your web request as well as dynamic parameter values, people can attack that component of the web request and look for SQL injection. There's so many little things like this that are in ASP.NET that you're going to need to learn to be ready for. You're going to need to learn to be on the lookout for. So when you take the class, this is the kind of stuff that we're going to teach. So like our first day, we're going to kind of get you up to speed on the fundamentals of ASP.NET security, input validation, output encoding, session management, all that kind of stuff. Show you all the secure libraries that you really need to be conscious of. But then after that, we're going to need to get right in there and get down in the weeds and do some real hacking, right? So here's another example. Let's say I do a tick or one equals, let's do a tick or one equals one, dash dash, and you'll see that I got a valid SQL injection. Okay. So here you are, you've got request validate, which should be stopping normal SQL injections. But you're going to learn that that list that's in there is almost like an access control list. It's only got a few of these cross-site scripting and SQL injection strings in it that it's looking for. And that's what it blocks. So if the attacker understands these things, he can do some pretty sneaky things to get right by these things. So it's not impossible. I don't want you to think that, oh, just because I tried A equals A like this, and then it blocks me, you guys are seeing that that's not working, right? So you do tick or A equals A like that, right? And you see that I get this error. These are the kinds of things that make people think, oh, well, SQL injection must not be possible because you can see that web.config security stuff is blocking it, right? But that's not always the case. And what happened here was this is just one of the exact strings that's in the request validate list, right? Like it's access control list, basically. If you try one of the strings that's not listed in there, like Joe tick or one equals one dash dash, you're going to see that it works beautifully. SQL injection works, cross-site scripting works. You don't just say to yourself, oh, request validate will take care of me. Oh, the anti-cross-site scripting library will take care of me. That's just not the case. There's so many little things in here, right? Other things that you want to be conscious of are things like XPath, XQuery. So again, I know I'm going really fast here, but I'm almost out of time. That's why I'm kind of speeding up. So you definitely want to think about things like XPath, XQuery. I'm going to give you guys an example where you would think that it's a login bypass, but that's really not what's going on here. If you take a real close look, it's tick space or space 1 equals 1 space or space single quote equals single quote. That's what I put into the address bar. That's what I put into the username bar, and then I just threw in a couple of things. So now when I click log in, you'll see that this bad boy has got me logged in as admin. So we've got an admin login. This is a login bypass, and this login bypass works even though it's not an SQL injection. So let me log in with a valid account. I'm going to log in with my user account, Joe. And let's say, for example, here's another one that a lot of people don't know about. In a lot of cases now, you'll have things like this. I'm going to start my tamper. I'm going to go to my profile setting, and I'll tamper with it. And you look right in the cookie. You've got admin equals no. And if you just change the session cookie, you can change it to admin equals yes. Driving the website as admin. And a lot of people think, well, I'm using view state, so you shouldn't be able to see all that because it should be encoded, but that's not necessarily the case. Here you can see that view state is in use along with your typical cookie data. Okay, next one. CT100. Okay, next one, I'm going to do my tamper data one more time. So I go tamper data, I'll start it. I'm on the profile section of the page. I'm going to hit that, I'm going to tamper with it. And if you look right here, CT100, content, middle, 24 hidden, here's a hidden form field. Well, that's pretty interesting, but what a lot of people don't often test for are vulnerabilities like this. So here, I'm going to pipe it and run the set command. And you'll see right now, I've got command injection. Full-blown command injection. So that's environment variables. You're reading a local file system. You can hit the back button and we can do it again. Right, maybe you want to pipe it to ipconfig. For some reason that didn't catch up with me. Usually the ipconfig trick works there. I guess it's only set for some reason today. I have to check that. I'll look at that source code in the back and see what's going on with that. Okay. All right, last thing, and then we'll wrap it up. So last thing that I think is really interesting is if you look, we got a contact us form. Please. So I'm going to turn off tamper data, and I'm going to log out. I don't need to be logged in for this. Okay, last thing, we're almost out of here. Okay, so I'm logged out of the website, and if you scroll down to the bottom and look, you see that there's a contact us form. So when you hit the contact us form, my God, where's this doggone tamper data? Stop the tamper. Okay, that's gone. All right, so now I'm going to hit the feedback form. Whoops. I'm going to hit the Contact Us form. And when you look at the Contact Us form, you see that it references a file. OpenPage.asp, ASPX, question mark, file name equals Contact Us. That's definitely not cool. So if you look at that, you've got a page that's referencing a file, right? So the first thing that you always test for, question number 1, does the website talk to a database? Question number 2, can I or someone else see what I type? Question number 3, does the website reference a file? So talking to a database, that's parameter passing. That's when you try for injection vulnerabilities. See what I type, forum, blog, guest book, contact us form, feedback form. You know, those are abuse of trust vulnerabilities. That's where you go for cross-site scripting, right? File references, like here, file name equals contact us.txt. If you can open local files on the file system, you need to try for like .flash, .flash, boot.ini like this. And you're seeing that that's working. Okay, now we can read local files on the file system. Well, if we can read local files on the file system, remember that file that sets all of our configuration stuff? Remember, web.config? So we open up that web.config file. Now it looks blank, but if you say view source, you'll see when you look at that bad boy, you'll see when you look at this bad boy, look here. UID SA, password equals not for you to see. We've now got admin access to the database. All right, guys, we're at 10 after 11. It's about time for questions now, so I'm going to stop here. It's going to be the end of my demo. Let me pop up. There we go.